Hello everybody, welcome back to my channel. Today we are going to start building the MMC. I have one of the capacitors that I'm going to be using and one of the resistors in front of me. I have 20 of these. I'm going to do two series strings of 10 in parallel, so I'll have 20 capacitors in total. I have these 1 megaohm 1 watt 10 kilovolt rated resistors. I have 20 of those. They all go across each of these capacitor legs and act as a bleed resistor. The capacitors won't store any electricity because the resistor will drain it back down to ground. So I'll show you how we're going to do it. If I do that and then raise this up slightly, there we go. I think there we go. So I've drilled all the holes in this shelf that's going in the cabinet that you've probably seen on the other videos. So what I'm going to do is start by pushing them through the holes. As you can see, my OCD has kicked in and I've bent all the legs exactly the same, so all of the labels are in the same direction. So all of them will go through. Ooh, I'll put that one in upside down. So then they will all slot in. These capacitors are all rated for 2 kilovolts, 2000 volts DC. They're also 0.15 MFD. They're pulse rated capacitors. Cornell Dubria, I think they are. I never pronounce it right, I don't think. I've got 10 of these on my dual ZBS board, the Tesla coil, and they work really well. Don't get hot. Just put that one in upside down and that one. Sorry guys. So each string of 10 will be rated at 20,000 volts. But my power supply is only going to be 4 kilovolts. But the reason I've done a larger than resonant MMC bank is because of the massive radio frequency high voltage. I can poke all of these down now in your pot. this is basically how it's going to look. These ones have just fell through on their own. Just the back one. So that's the capacitor bank. Put a lump of wood under there. There we go. So the capacitors are going to go either side, like so, and then my rotary spark gap is going into these 4 holes here, and I will have 2 RF chokes that I've still got to make. I'm going to make those and record me making it, so you can see how I make those. So when I turn this over and go underneath, I'll join all of these outer legs together, and then either at this end or this end I'll join these 2 together, and then one side will become the input, one side will become the output, or vice versa. So I'll turn it over and start soldering. Just give me a second, I'll pause it here and then come back to you. Hello everybody. Yesterday we got the capacitors put onto the board. We're doing 2 rows of 10 in series, so these will be connected in series, and then they'll be wired in parallel also. Today, after I've done all the shrink tubing around all the legs, push them through, now we're starting to put the resistors in. Just move that pen, there we go. So these resistors are 1 megaohm resistors. They are 1 watt, 10 kilovolts. They're rated for 10 kilovolts, which I thought would be plenty for a 4 kilovolt system. And today we're going to put all of these resistors in, and with the pieces of wire I'm going to do things like not there, but join the top and the bottoms of the capacitors together, so there and here, and then there'll be one here, there'll be one here, and these 2 ends will be open. So what I've been doing is I've just been getting the resistor, showing it up to the hole using a pair of pliers, and then turning it 90 degrees, just give that a bit more of a tweak, and then this side tweak that like that, so we've got them like that. Then what I've been doing is just pushing them in the holes here and here, And then what I'll do is I'll run a piece of solder across each end of these to join them together. And all these smaller pieces of copper going across each capacitor to make it into not in each capacitor leg to make it into a full capacitor string. So all of those will be joined, then this will go across here, and then this side I've got one more resistor to put in, and then join all these capacitor legs together. I could have put the capacitors closer together and not had a gap to fill here, but I wanted my capacitors to be far enough apart so that the side that you can see underneath the capacitors, I don't want it arcing from one leg to the next. So that's one reason I put the shrink tubing in, and the other reason that they are further apart is to stop this side from arcing to capacitor, from capacitor to capacitor. Also, when this is finished, the top side, everything will get a coating of polyurethane varnish to protect it. This side, I'm either going to cut some small strips of wood and put it around and fill this with resin, both sides, or I may even just coat this with polyurethane varnish and then just see how it goes. If I start getting flash over, then maybe I'll pot it, but I've tried to do it far enough apart so that I don't get flash over across from one side to the other. And I think a couple of coats of polyurethane varnish should be enough to protect it. It has been on my other previous builds, and the dual ZVS flyback transformer Tesla coil, that's running at a lot higher voltage than this, and the way I've built that is working. So I'm just going to repeat the same process with this one and keep my fingers crossed that it works. So I'm going to put it on time lapse now, and you can follow along as I put all this together, and then decide whether I'm painting it with varnish or potting it. So now we have all of the resistors mounted into the board. They aren't soldered yet, but that's what we're going to be doing next. What I like to use is a little bit of this flux. It just makes soldering a lot quicker, so I'll just get a little bit on my brush and start painting everything where it needs to be, like this, all the way down. Oops, go back there. So we get all of these coated with flux. Oops. Right, we'll get all these done. I'm repeating myself, I'm sorry. I think we'll do the rest of this on time lapse. So we've got everything soldered now. Everything's all joined together. We've got 2 rows of 10. So I put these bolts in to be my electrical connectors, but they're way too long, so I'm going to get some shorter ones. So basically what will happen is top of column 1 will go to top of column 3, top of column 2 will go to the top of column 4, and that will join them 2 series strings into parallel, and then we can take our input and output from the bolts. I'm going to change those to shorter bolts. So I'm wondering whether to pot these or just give them a generous coat of polyurethane varnish. What do you think? Do you think I should pot them, or do you think I should just varnish it all underneath to protect it and to give it some electrical insulation? Comment down below, let me know what you think, whether I should put a frame around these and fill it with resin both sides, or just paint it with polyurethane. So this side's finished apart from the potting or urethane in. The other side looks nice. As you can see that I've already polyurethane the board. These screw holes are for the spark gap. This side looks a bit scruffy, but it's the bottom. All of these little spots I will touch up with urethane if I don't, polyurethane if I don't pot it. So this side's finished. I will go round on each of the capacitor ends and put a bit of polyurethane, a dab of polyurethane on the top here, and then on the underside I just need to pot it, or I can't decide. Please comment down below what you think could be better. And as usual, thank you for watching. Please like and subscribe to follow on. The next job is wiring the microwave transformers into the cupboard that I've built my Tesla coil on. I'll be wiring those in anti-parallel level up formation. So if you're interested in seeing what that's all about, please like and subscribe and follow on the build. That's next. Thank you.